Multiple choice question number 3 says a lamp, a voltmeter, and an ammeter, and a battery with zero internal resistance are connected as shown above. And so we have this kind of sketch that given to us. By the way, this concept of zero internal resistance simply means the battery is ideal, and we don't have to consider that there's any additional resistances inside the battery itself. And connecting another lamp in parallel. So if we connect another lamp in parallel with the first lamp as shown, what happens to the ammeter and voltmeter, et cetera, et cetera? Well, we should see that the voltmeter is measuring the potential difference between the top and the bottom here like that. Now, technically, the connection points are a little different, but it's measuring the potential between the top leg and the bottom leg. And as we add more lamps, that doesn't change that fact. So it's not going to change the voltmeter reading in any way. So C and D are immediately incorrect. It still could be E. And so now the question is, what happens to the ammeter? Well, adding lamps, or in this case, resistors in parallel, decreases the equivalent resistance and increases the amount of current leaving the battery. Let's remember V is equal to IR. And so if R goes down with a constant battery voltage for the total system, then that means that the current leaving the battery is going to increase. And the current leaving the battery is the current that's going through that ammeter. And so by adding resistors in parallel, it decreases equivalent resistance. How do we know that? Well, remember, 1 over Req is equal to 1 over R1 plus 1 over R2. And so as you keep adding resistors, the equivalent resistance goes down. It's a little counterintuitive, but if you were to plug some numbers into R1 and R2 and perhaps trying even adding a third one, you would see that the equivalent resistance goes down. And so therefore, the correct answer is A, the ammeter reading goes up.